Okay, the unit circle is used to understand the sines and cosines of angles found in right triangles. The unit circle has a center at the origin and a radius of 1. Okay, we kind of talked about this with our triangles. Okay, are all of our 30, 60, 90, and 45, 45, 90 right triangles are similar to each other with that common ratio? Okay, all circles are going to be similar to each other because it's just the radius that we take the measure of, right? So any radius can be proportional to each other. Okay? So that's why we take the unit circle and restrict it down to 1, because it's going to be similar in all of our circles that you ever would have. So this right here is your radius. Okay. This is the radius of 1. The hypotenuse is always the radius in your triangles, just so you know. To find the sine and cosine of an angle, you find the point x and y. Okay? X represents the cosine, and y represents the sine. Cosine and sine. Okay, this is very important to remember. Okay? So I always remember that it's alphabetical order. Cosine first, then sine. Because x and y are also in alphabetical order. So cosine, then sine. Okay. The whole point of this is to be able to find the cosine and the sine of a given angle. This right here is going to be our reference angle or our central angle. Okay. And then we're going to find the cosine and the y value. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. It always goes counterclockwise. 1, 2, 3, 4. Okay, so cosine and sine are all going to have the same kind of values throughout. Okay, as you're going through this, you'll see that 1 over radical 2 is a sine and cosine for various angles. The issue is as you move around the unit circle, they're going to be different signs. So they're going to be positive or negative, 1 over 2. Okay? So in quadrant 1, if the cosine, right, cosine is positive here in quadrant 1. What about cosine here? The x value. Over here, what's that? Positive or negative? Negative. So the cosine will be negative here. What about here? It's negative, so cosine's negative here. How about here? Positive. Okay. So right here, cosine's going to be positive on this side of the graph because x is positive here. On this side, cosine's going to be negative because the x value is a negative on this side. Sine values will also be different. So sine is positive up here, but if the y values are positive up here. Down here in your angle, if you have our angle drawn in here, in one of these quadrants, then it's going to be negative. Okay? It's very important that you know where sine and cosine are negative and positive. So we teach you a little trick here. Okay? Our little trick is the acronym All Students Take Calculus. The A stands for all are positive. In quadrant 1, they're all positive. All of our trig functions, sine, cosine, and tangent, are all positive. Then the S here stands for sine is positive. So in this quadrant, just the sine is positive. So tangent and cosine are negative in quadrant 2. This is tangent is positive. in quadrant 3, tangent's the only thing that's positive, cosine and sine are both negative. And then C is cosine. It's positive. And so in quadrant 4, cosine that's positive and sine and tangent are both negative. Any questions about that? This is just an easy way to check to see if our sine and cosine are negative and positive. And you'll make more sense as we continue on. Any questions over that? Let's move on. Okay, so this is what we just kind of reviewed a little bit with you. Okay, on 30, 60, 90 right triangles, please write it in if you can't see it because it didn't copy very well. So draw the triangle here. Draw the ratios. This is 1. Make sure across from the 30 degree is always a 1. Across from the 30 or opposite the 30 degree angle, the ratio is always 1. Okay. The hypotenuse is always 2, and then the square root of 3 is always opposite the 60. Okay. I had them when I got here. This is 1, this is square root of 3, and this is 2. They all go together. 1, square root of 3, and then 90 is 2. Those are opposite those angles. If you cannot properly place the ratios, you're going to struggle this whole chapter. Because if you put them in the wrong spot, you're going to get the wrong answer. Okay, so make sure you can put them where they're supposed to go. For a 30, 60, 90 right triangle, okay, if the central angle, the angle right there is 60, this one was 30, so across from the 30 was the 1. Here, now the central angle, okay, is 60, so across from this is the square root of 3. So again, this is 1 square root of 3 for a 60, and then 2. The hypotenuse again is always 2, and now here is 1 because the 30 degree angle is here. Any questions over that? The 45, 45 is pretty easy because it's just 1, 1, and then the 90 degrees always the square root of 2. So it's a little easier to write down. Please again draw in the triangles if you can't see them. Make sure you're putting the ratios in the right spot so you know how to use them. In the unit circle then, how they deal with this is they need to make this radius of 1. So what they do is take the radius that's actually 2 and then just divide everything by 2 to get the radius to be 1. So 2 divided by 2 will be 1. Then square root of 3 divided by 2 is the square root of 3 over 2. Then 1 divided by 2 is just 1/2. And again, this is the cosine, and this is the sine. So the cosine of 30 degrees, because here's my central angle of 30 degrees, is square root of 3 over 2. And the sine of 30 degrees is 1/2. It's in quadrant 1, so they're both positive. And that's how the unit circle works. Any questions over that? On the back, we're going to find reference angles. Okay, reference angle is the angle that the terminal side of an angle makes with the x-axis. Circle that. Never the y-axis. Always the x-axis. Okay? Never, ever do we do a reference angle to the y-axis. It's always to the x-axis. So to find the reference angle of the given angle, we're going to first graph it. So we're going to graph 120. So this is 0, this is 90 degrees, this is 180 degrees, 370 degrees. This is 360 degrees. Any questions? So when I graph 120, here's my initial side, and 120 is going to be kind of over here. So this right here is 120. And now I always draw the arrow, so I show which direction I'm going. I'm going to draw a perpendicular line to the x-axis. Always the x-axis. So now this is my right triangle. This right here is my reference angle. That's my reference angle. Any questions over that? Yeah, it's the one in the middle, not the 90? Not the 90 degrees. It's the central angle. Central angle, the one at the center of your X and Y graph. And then to find that central angle, I drew this to 180 degrees. So how many more degrees do I need to get from 120 to 180? 60. I just take 180 and I subtract it from 120 to get 60 degrees. So your reference angle is 60 degrees. Any questions over that? Your reference angles are always going to be one of the three angles we talked about. 60 degrees, 30 degrees, or 45 degrees. It's going to be one of those three. If it's something else, you've done something wrong, go ahead and fix it. Does that make sense? Okay, next one, 225. We'll do the same steps. Let's graph it. Let's write this in 0, 90, 180, 270, 360. So my terminal side is going to be right here. And again, I want to draw a perpendicular line to the x-axis. So I'm going to go from here to here, never to the y. And we're looking for this right here, this angle. This angle here with my 225. I want to know the central angle of this triangle that I just created now, which is my reference angle. Anyone have an idea of how I'm going to find that? Am I going 270? Yes, I'm going to 180, so I'm going to do 225 minus 180. And that's going to give me 45 degrees. So this is 45 degrees. Any questions over that? We should notice if it ends in a 5 that the reference angle has to be a 45 degrees, right? Because my other options are either 60 or 30. And how do I do that? Subtract it from 180. I'm either going to be subtracting from 180 or subtracting from 360. If I draw the line to 360, then I'm going to subtract the 360. Here I drew the line to 180. So I'm subtracting from 180. Does that make sense? Okay, try the next one on your own. Negative 45. Oh, this one's actually, let me do it with you. This is different. It's not the same thing, right? So this is 0, this is 90, this is 180, this is 270, this is 360. But if I'm going to go negative, what's this actually if I'm going negative? Negative 90, right? So when I graph this, I'm going to go here, and then here. I draw it to 360, because that's the closest to the x-axis, draw the perpendicular, right? So the angle that should be here, very good. I went negative 45, so this has to be 45 degrees. So I could do 45 minus 0, minus 45. And it's going to be positive, because an angle measure is always a positive number because it's a distance. Okay? So I'm never going to get a negative 45 degree reference angle. The negative 45 just tells me what quadrant to graph it in. And since it's negative, I had to graph it down into the 4th quadrant. Any questions over that? You all good? Okay, let's finish our sine, cosine, and tangent. We already kind of talked about this. Okay, this is so, SOA. That's how you remembered it last year in geometry. We talked about SOA. And so sine equals the opposite over the hypotenuse. Any questions over that? The cosine then equals the adjacent over hypotenuse. And then the tangent equals the opposite over hypotenuse, or adjacent, sorry. Any questions over that? We also have to write one more thing for tangent that's kind of new. Tangent is also sine over cosine. You want to remember both of those ratios. Today we're going to be dealing with just the opposite and adjacent for this section, but I think next section we're going to use sine and cosine. Any questions over that? All good? Okay, we'll finish these notes tomorrow. Your trig 1 is due tomorrow. Okay? And your TQ number 6 is due tomorrow.